Hello and welcome to my advanced geometry video. This is for chapter 2, section 3. It is on deductive reasoning. So first thing we start out with is a definition. Deductive reasoning or logical reasoning is the process of reasoning logically from a given statement to a conclusion. We've already learned about inductive reasoning, which is a reasoning based on patterns. So reasoning based on patterns. So this is like the worksheet where we got the tables and we had to figure out the next successive numbers, or we had to come up with some sort of rule given the pattern in the table. Deductive reasoning is where mainly what we do in geometry, we're going to use theorems and postulates and definitions and things like that to logically reason from one statement to the other. So the first example they have, it says that an auto mechanic knows that if a car has a dead battery, the car will not start. The mechanic begins to work on the car and finds the battery is dead. What conclusions can you make? Most of us can figure that out pretty easily. The car will not start. Now, even though we can all do that, what we need to know is what allows us to do that. Why is this reasoning okay, and what is good reasoning, what is poor reasoning? The reasoning we just used is called the law of detachment. Okay? So the law of detachment is a law of deductive reasoning. And here's what it basically says. If a conditional is true, so we have a true if-then statement, and the hypothesis of that conditional statement is true, then its conclusion has to be true. So in order to use this, we actually have to have two things that are true. We have to have a true conditional statement, okay? And then we also have to have a true hypothesis in that statement. So I can say something like, if it is Wednesday, we have the mid-chapter 2 quiz. And that's a true statement. But it's not Wednesday. So the hypothesis currently is not true. Now, once that hypothesis is true, then we can say the conclusion is true. We have a quiz. Okay? So basically we have that symbolic form. If P then Q is true, and P is true, then Q also has to be true. So here's another example. For the given true statements, what can you conclude? If M is the midpoint of a segment, then it divides the segment into two congruent segments. Okay, so this is a true conditional statement. Now we have a different scenario. We have M is the midpoint of AB. Okay? So now they give us a true hypothesis. M is the midpoint of AB. Then we can say that M divides the segment into two congruent segments. Now, if I gave you, if M is the midpoint of a segment, then it divides the segment into two congruent segments. And then I say, you know, P is on segment AB. Okay. That doesn't make the hypothesis true, so we wouldn't be able to make any sort of logical statement from that. Okay. The next law we have is the law of syllogism. Most of the time we call it syllogism, something like that. And this one says that it's basically like a transitive of conditional statements. You actually have two conditional statements and you're going to link them together. And the conclusion of the first one is going to be the hypothesis of the second one. So this one says, if P then Q and if Q then R are true, then P then R is also true. So we're kind of doing something like this. If P, then Q, and if Q, then R. And we can go right to, well, then if P, then R. And as long as both of those conditional statements are true, then we can use the law of syllogism to do this. Okay. So use the law of syllogism to draw a conclusion from the following true statements. If a number is prime, that it does not have repeated factors. Okay, true conditional statement. if a number does not have repeated factors, then it is not a perfect square. Also a true statement. Now, the one thing we have to check is that the conclusion of the first statement is the hypothesis of the second one. In this case, it is. And then what we can kind of do is we can kind of link it from the first to the end. So now we can say, okay, if a number is prime, then it is not a perfect square. And then we have another example that's going to link them both together. Use the law of detachment and the law of syllogism to draw conclusions from the following true statements. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. The Nile is 4,000. The next example, what they want you to do is they want you to use the law of detachment and the law of syllogism to draw conclusions from the following statements. What I want you to do is take a look at the statements and don't rush to immediately say, okay, this is what they're saying. Make sure that you can recognize where you're going to use the law of detachment, where you're going to use the law of syllogism, how you're going to put them together, and that way when you come up with your, what you're going to deduce, you have a reason to back it up. This is where I use law of syllogism. This is where I use law of detachment. Have a great day. Thank you for watching.